In the earlier parts of this training, we explored how GIS helps us understand natural systems, plan sustainable resource use, and support operational decision-making across different sectors. Now, in this section, we turn to real case studies, practical examples that show how these concepts translate into measurable outcomes. The capabilities we discussed, spatial analysis, planning workflows, real-time monitoring, and operational resilience, become far more meaningful when we observe how they perform in real environments. Case studies allow us to see how organizations apply GIS under real pressures, where it reduces risk, where it improves efficiency, and where it enables more responsible use of natural resources. These examples move us from theory into practice. They show how institutions integrate GIS into daily workflows, how it shapes strategic and operational choices, and the tangible benefits it delivers in mining, energy, forestry, agriculture, and beyond. With these cases, we can clearly see how GIS is transforming natural resource management today. In this next section, we shift from concepts to real-world practice by looking at 4 diverse case studies in natural resource management. These examples come from different countries, sectors, and operational challenges, yet they all show how GIS turns spatial data into smarter, faster, and more sustainable decisions. We will see how Finland uses artificial intelligence and lidar to manage forests with remarkable accuracy, how Argentina optimizes fuel deliveries in real time, how Kentucky identifies the most suitable sites for solar energy development, and how Florida keeps local agriculture moving using smart maps during times of disruption. Together, these stories demonstrate a common message. When organizations build strong spatial systems, they gain clarity, efficiency, and resilience across their operations. These real-world applications help us see not just what GIS can do, but what it enables people to achieve in the field. Finland. Artificial intelligence, robots enhance forest sustainability. Let's begin our first case study with Finland, a country that is redefining forest management through high-accuracy spatial data and artificial intelligence. In the planning phase of this effort, Finland set out to build one of the most accurate forest inventories in the world. They used high-resolution aerial imagery and lidar to capture the true structure of their forests, not just where trees are located, but their height, density, and condition. What makes this approach truly transformative is the integration of artificial intelligence. AI models now estimate tree species, height, and volume automatically, eliminating the need for extensive fieldwork. Decisions that once required days or weeks of on-site inspection can now be made in minutes, directly within the GIS environment. All this information comes together in a unified GIS platform that allows forest owners, operators, and agencies to evaluate forest value remotely. They can plan harvesting, assess risks, and understand long-term sustainability without setting foot in the field. By establishing such a precise spatial foundation, Finland is not only improving forest management today, it is preparing the entire sector for automation and robotics. Accurate data becomes the backbone of future machine operations, enabling more efficient, safer, and more sustainable forestry. In the second part of this case study, we look at how Finland's forest data strategy moves from planning into real operational impact. The Open Forest Data Portal is a major step in this transition. It gives owners, operators, and agencies instant access to reliable, high-accuracy forest information, anytime, anywhere. With this level of accessibility, decisions that once required physical field visits can now be made remotely. That shift doesn't just increase convenience, it improves transparency, reduces costs, and speeds up the entire decision-making process. Another important outcome is the creation of automation-ready datasets. Because the data is so precise and standardized, it can directly support precision harvesting, automated monitoring, and even future robotic forest maintenance. This means daily operations are gradually becoming safer, more efficient, and more data-driven. All of this is tied together through GIS workflows that guide sustainable, long-term forest management. Finland's approach shows how high-quality spatial data can transform everyday operations, making sustainability not just a strategy on paper but a practical, measurable reality in the field. The Finnish Forest Center has a very clear objective, not only to keep forest data updated, but to make it reliable, universally accessible, and directly operational. Today, high-resolution imagery, lidar data, AI models, and GIS-based workflows make it possible to make accurate decisions without ever having to go into the field. This reduces costs while providing the transparency required for truly sustainable management. The essence of this vision is beautifully captured in Tapani Hamalanan's words. We want the data to be so accurate that users can see and sell without having to go to the forest. In other words, the goal is to ensure that the data is so precise and so trustworthy that a forest owner no longer needs to physically visit the forest to make informed decisions. This vision sits at the heart of modern natural resource management, where the spatial accuracy, automation, and confidence offered by GIS help build a stronger economic and environmental future. Argentina optimizes fuel deliveries with real-time GIS. In our next case study, we look at how Kuwait Oil Company transformed its operational efficiency by building one of the most detailed and comprehensive geodatabases in the region. In a landscape crowded with thousands of wells, flow lines, gathering centers and cables, KOC faced a major challenge: understanding exactly what existed on the ground and beneath it. To solve this, teams conducted high-precision surveys using GPS, ground-penetrating radar and lidar, mapping every relevant asset into a unified geodatabase. A standard data model and multi-user versioning ensured data consistency and supported simultaneous editing across departments. This strong geospatial foundation became the backbone of Kuwait's long-term oilfield development strategy, helping reduce congestion, optimize land use and plan future infrastructure with far greater accuracy. We look at how PAE's new real-time GIS system immediately improved the entire delivery process. What you see in the image is more than just a map, it's a complete operational picture. The platform allows staff to monitor every delivery, track the status of tanker trucks, and understand exactly how the fleet is performing at any moment. For customers, this means shorter waiting times, clearer communication, and far more reliable service. Instead of broad delivery windows and uncertainty, they now receive timely updates and accurate expectations. This system gives both sides, operators and customers, greater confidence, transparency, and efficiency across the whole distribution chain. In this slide, we focus on one of the most important operational advantages: compliance. With the GIS dashboard shown here, staff at PAE can see exactly where each tanker truck is during its route. This constant visibility allows them to ensure that drivers follow approved routes, respect safety regulations, and maintain proper delivery timing. If a delay, detour, or risk emerges, it becomes visible instantly. This not only improves safety but also protects the organization from regulatory issues, reporting challenges, and operational uncertainty. In short, real-time tracking turns compliance from a reactive task into a proactive and continuous process. To close this case study, let's highlight what makes the PAE example so powerful. By adopting a real-time GIS system, the organization transformed fuel delivery from a reactive, uncertain process into a coordinated and transparent operation. Staff gained continuous visibility over tanker movements, customers received more reliable service, and compliance became far easier to maintain. What this shows us is that real-time GIS is not just a mapping tool, it's an operational backbone. It strengthens decision-making, reduces delays, and builds trust across the entire supply chain. Just like our previous case, this example demonstrates how spatial intelligence turns complex natural resource operations into safer, faster, and far more efficient workflows. This is our third case study, and we move from fuel distribution in PAE's network to renewable energy planning in Kentucky. Kentucky has a long history as a coal powerhouse, but today it is actively positioning itself as a strong candidate for renewable energy investments, especially solar. As solar projects became more affordable and interest from developers increased, the state faced a key question: where should new solar sites go? ESRI, the Kentucky Energy and Environment Cabinet, responded by building a GIS-driven platform called Solar Site Potential in Kentucky. This system helps identify prime locations for solar development across the state while still protecting local communities and sensitive environments. In the next slides, we'll look at how they designed the suitability analysis and how the platform supports real-world decisions. If we take a closer look at Kentucky's GIS-based suitability model, we can see how it transforms site selection into a structured and objective process. Instead of relying on manual evaluations, the model integrates all critical criteria: slope, land cover, access to transmission lines, protected habitats, reclaimed mine lands, and key community factors, into a single analytical workflow. Each parcel is automatically scored based on these inputs, allowing planners and developers to compare locations with clarity and consistency. What makes this approach so valuable is its ability to highlight not only which areas are technically feasible, but which ones offer the best long-term balance between feasibility, environmental sensitivity, and sustainability. By making suitability transparent and data-driven, the model significantly reduces uncertainty and helps guide investment toward the most responsible and promising sites. Through the solar site potential in Kentucky application, the role of communication in renewable energy planning becomes much clearer. Community stakeholders can access this interactive map and immediately see which parcels are being evaluated for solar development. The tool is not just for developers, it offers a participatory space for residents, planners, and land use officials as well. By turning technical data, suitability scores, land use types, transmission corridors, into clear visual layers, Kentucky grounds renewable energy discussions in shared geographic understanding rather than isolated proposals. This transparency reduces conflict, builds trust, and makes the planning process more inclusive. The application also opens new opportunities. Other states are now looking to this model to answer key questions before proposals are even submitted. Where should solar go? What lands should be preserved? What risks should be considered? Kentucky's approach demonstrates how GIS can guide these decisions spatially and transparently. When we talk about resilience in natural resource systems, we often think about forests, energy networks, or water infrastructure. But the COVID-19 period showed us that food systems also need to be resilient, able to adapt quickly when normal distribution channels slow down. This case study shows how the Florida Department of Agriculture and Consumer Services used GIS to strengthen that resilience. During the pandemic, many farmers suddenly had large volumes of unsold crops simply because traditional sales pathways were disrupted. To respond, FDACS brought together agricultural experts, technologists, and GIS teams to build a smart map-based solution. Using ArcGIS Online, they created a public platform where farmers could list available products, residents could find nearby suppliers, and organizations could support Florida-grown goods more transparently. This illustrates how smart maps do more than display information. They keep local food systems connected, adaptive, and economically stable, even during periods of rapid change. In this slide, we focus on how the platform created by FDACS became a truly interactive experience for local residents. Using ArcGIS Online, the team built a simple but powerful web application where anyone in Florida could instantly find nearby producers, see what products were available, and connect directly with farmers. Residents could open the map on their phone, filter by product type, explore farm details, and even get directions with a single click. This level of accessibility turned what could have been a data-heavy system into a user-friendly community tool. What's important here is the transparency it brought. Instead of relying on long supply chains, people could identify exactly where their food was grown, who produced it, and how to support local agriculture. This not only strengthened the connection between consumers and farmers but also helped keep Florida-grown products moving at a time when traditional channels were struggling. As we close this case study, we can clearly see how smart maps played a central role in keeping Florida's agricultural system resilient and connected. What began as a rapid response to disruptions evolved into a long-term digital asset that continues to support farmers, businesses, and communities. By mapping producers, products, and distribution points in real time, FDACS created a system that helped move Florida-grown food efficiently from fields to consumers. Instead of relying on broken or delayed supply chains, the state enabled a direct, transparent, and reliable flow between farmers and residents. This case shows the broader lesson. GIS doesn't just visualize data, it keeps systems moving, even when conditions are uncertain. Whether it's agriculture, energy, or natural resources, these tools help organizations stay coordinated, informed, and resilient in delivering essential services. As we look across all 4 case studies, a clear pattern emerges. Regardless of sector, geography, or operational challenge, GIS consistently elevates how natural resources are managed. Finland shows us that highly accurate spatial data, enriched with AI and lidar, can completely transform long-term sustainability planning. Argentina demonstrates the value of real-time awareness, where a single operational picture improves efficiency, safety, and customer confidence. Kentucky illustrates how data-driven suitability analysis helps guide renewable energy investments toward the most responsible and promising locations. And Florida reminds us that smart maps are not just technical tools. They keep communities connected and supply chains functioning even when traditional systems slow down. Together, these cases highlight a core insight. GIS is most powerful when it connects people, data, and decisions into one coherent system. It enables clarity in planning, precision in operations, and resilience across natural resource workflows, turning complex challenges into manageable, measurable outcomes. As we reflect on the entire module, the most important takeaway is that GIS is far more than a technical tool. It is a framework that improves how institutions think, collaborate, and act. We've seen how spatial systems unify information across departments, support coordinated responses, and scale from local tasks to statewide strategy. When teams share the same geographic picture, they communicate more effectively, reduce friction, and make decisions grounded in evidence rather than assumptions. Most importantly, GIS allows organizations to shift from reacting to problems toward anticipating them. Whether managing forests, energy networks, agricultural supply chains, or renewable energy development, GIS builds the maturity and foresight needed for sustainable, future-ready operations.